question, as you can tell, has an I term in it, so it's a complex number question. Do you remember what does it mean to be simplified? If I said 4/8, what would you tell me? You mean 1/2. So simplified, when you get to complex numbers, means we do not want to see an I on the bottom, on the denominator. So how can we remove the I term from the denominator? It's okay at top. So remember, I at top is okay with complex numbers. So the trick to this beast happened to be something called a conjugate. You always take the conjugate of the denominator. The simple way to remember it, all you do is change the sign in the middle. And it comes into a FOILing thing where something will cancel out. We're going to show you that. So we're going to multiply top and bottom by 2 plus I. 2 plus I, that's the conjugate. Now notice, I said multiply top and bottom by that term, and that's when you're dealing with fractions. To keep it equivalent, you have to multiply by 1. So this is multiplying essentially by 1. It's an ugly one, but it's 1. What did a lot of people do? They kept it as 2 minus I, and they only multiplied the top, and they canceled the terms. That's illegal. Why? Because it has to be equivalent. You can't just multiply by anything. You have to multiply by something that's equal or equivalent to 1. So now that you have this, you have to remember how to multiply fractions. And I know fractions are the devil for many people. Fractions is simply top times top. So let's check this out. What's 5i times 2? 10i. And then what's 5i times I? Turns out to be plus 5i squared. So believe it or not, the multiplying across really got people in trouble. You multiply each term by the 5i. And before you start simplifying, you know that I squared is equal to -1. Before you start simplifying, let's go to the bottom. And you look at, do FOILing it. What's 2 times 2, Scooby-Doo? It's 4, right? And then you go the outside terms. What's 2 times a positive I? 2i. 2i. Now some of you can do this in your head, but it's really safe to show your steps because you get more partial credit. Then the inside, what's -I times 2? It's a -2i, thank you. And the last part, this is where people make mistakes. Look at this. That's a negative or opposite I times a positive I. That becomes a -I squared. And that's where people get in trouble. We're going to show you that next step. Now that you have everything multiplied out, let's look at doing substitution. Wherever you see an I squared, make it a -1. Now watch this. This is careful. What happens when you have an opposite of I squared? That's the opposite of -1, which makes it a positive 1. So this becomes 10i minus 5 all over. Wait a minute. What happens to the 2i and -2i? Whoop, whoop! That's why we did the FOILing and the conjugate, so they cancel out the middle terms. And you have 4. This becomes a plus 1. The denominator should be 5. Now let's talk about that denominator. How come that is so much prettier than 2 minus I? It doesn't have any imaginary numbers, and that means it's simplified. You're looking gold. The last piece said put it in standard form, though. So let's look at this. Do you notice I have 10i minus 5? Can I rewrite that using the commutative property to be -5 plus 10i? You'll see why I'm doing that, because I want the I on the right side to be in standard form. So when you communicate in math, there's certain expectations you want to keep. Now again, who would have ever thought fractions would keep haunting you? You have a common denominator. Can you actually break it into 2 fractions? Let's look at this. We'll break it into 2 fractions. It becomes -5 divided by 5 plus 10i divided by 5. The math actually looks pretty nice on this one. A -5 divided by 5 gives you a -1 up here. We're coming to the top. And what's 10 divided by 5? 2. Keep the I there. And now you have a simplified answer to that question. So good job.